Hello, class. Today we are going to talk about arc length and radians. So in the previous videos, we have looked at arcs as the measure of the arc. We're looking at angles. How many degrees have we moved around the center of the circle? And in that case, it doesn't matter how big the circle is. It's the same angle. It's the same measure. What we're looking at now is arc length. How much distance has been traveled around the circle, in which case now the size of the circle matters, right? If you have a teeny tiny circle and you move 5 inches around it, you might spin around that circle 4 or 5 times. But if you're looking at something with the diameter of the earth, 5 inches, you barely moved anywhere, right? So that matters. And so that's what we're going to look at. We are going to look at arc length and radians, which is a brand new thing. Now, before we look at arc length, which is distance, we're going to look at the distance around the entire circle, which we call the circumference. And hopefully you remember that the circumference is 2 pi r. 2 times pi times the radius, or you may see this as pi times diameter. Real quickly, I am going to find the circumference of this circle here. So the circumference is 2 times pi times my radius of 5, which is just 10 pi. And I am going to leave it like that as 10 pi centimeters. I'm not going to get the decimal for it. I just want to leave it like that. It's a little bit cleaner, nicer. It's not rounded off. It's the exact number. Now, I don't want the entire circumference. I just want to look at the length of the arc, the distance around part of the circle. So, for example, say maybe I just wanted 180-degree arc. Well, that's easy enough. 180 degrees, that's a semicircle, right? It's half the circle. So you just take your 10 pi times 1/2, and 1/2 of 10 pi will be 5 pi. Easy stuff, right? Well, what if I only want a 90-degree arc? Well, again, that's just half of a half. That's just a fourth of a circle, right? So we take 1/4 times 10 pi, and that's 5 pi over 2. It's 5 halves, 2.5 pi, right? And again, I'm going to leave it like this. This is a little bit cleaner than having some great big long decimal. But what if I want 30 degrees? Well, I don't know what fraction of a circle 30 degrees is, but I can find it real quick. I just need that fraction, right? Well, that's 30 out of the entire circle, which is 360. So we have 30 out of 360 times 10 pi. I want to simplify that fraction just a little bit real quick. So that would be 1/6 of 10 pi, which is 5 pi over 3. Because that'd be 10 over 6, which simplifies as 5/3. So we have 5/3 pi. And there it is. All right. But what if I just have some random, completely random angle? So what if I have something like this? All right. I have some random angle. I don't know how many degrees this is, so I'm just going to use a variable here. This variable, this is called theta. You may not have seen this before. It's just a variable that we use for angles. So I have some theta number of degrees and the length of my arc. Well, what this is, it's just a proportion, right? That's all we're doing. These ratios is proportional. The length of the arc, this little piece, over the length around the entire circle, which is circumference, 2 pi r, is equal to the degrees of this little piece over the degrees of the entire circle. Right? It's proportional. You can do it like that. You can take this and do cross products with this. Right? Right? Cross multiply, cross products. And if you do that, you end up with this formula here. Now, what I have done on this is I have switched, instead of having C for circumference, I have rewritten it as 2 pi r, because circumference is 2 pi r. So we have 2 pi r, circumference, times the angle over 360 is going to equal your arc length. Or this does simplify, right, because they're both divisible by 2, into just pi r theta divided by 180. Okay? Much easier. If you want to solve for the length, you want to use this. If instead they give you other information and say they want you to solve for the angle, use the proportion. All right. Okay, so now let's take a look. Let's do an example here. So here they give me a circle. We have an arc of 150 degrees, radius is 4 inches. I want to find x. So I am looking for the arc length. And since I'm looking for length, I am going to use the formula right there. All right, so let's take a look. So arc length, I don't know, that's x equals, and so we have, I'm going to use this one because it's shorter and easier. So pi times r times the degrees. So pi times r, which is 4, times my angle, which is 150 degrees, over 180. 180. All right, I do want to simplify my fraction since I'm here. So let's see here, let's multiply that out, and we have x is equal to 600 pi over 180. Those are both divisible by 60, so x is equal to 10 pi over 3. Now, depending on what the problem is asking you for, this may be your answer. This is the exact answer. Right here, this is exact. This is the exact answer. It has pi in it. It is not rounded off. And I can't spell today, apparently. This is the exact answer. Now, if it wants it rounded off, it wants to know, hey, how many inches is this to the nearest hundredth, to the nearest whatever. You can just take that, you stick it in your calculator, and you would get approximately 10.47 inches. All right? That is, depends on what the question wants. If it wants exact, you give them this. If it wants it rounded off, you give them that. All right? Not a big deal. So this is with degrees. The other thing we were going to talk about is radians. Radians are another way of measuring angles. Okay? Just like you can measure in inches or centimeters, you can measure in radians and degrees. So the first thing we want to talk about is, what is a radian? All right, and so here we go. So we have a circle, draw a circle, there we go. And that red segment there, that is the radius of the circle. And if we take that radius and we lay it against the circumference of the circle, this angle that it gives us, that is 1 radian. All right, so I move it over, and now I have 2 radians. Move it again, I have 3 radians. Notice it doesn't quite make a full half circle, but this extra little bit there, that brings it up to pi. All right, pi radians is half the circle, so the entire circle is 2 radians. All right, so when we're talking about radians, one circle is 2 pi. If we're talking degrees, one circle is 360 degrees, and it's on a loop. It's just going to keep going. All right, so that's our conversion. 360 degrees is equal to 2 pi radians. All right, so we can set this up as a proportion if I want to do some conversion. X over 360, x degrees over 360 equals radians over 2 pi. All right, cross products, and you end up with a conversion here. So degrees is equal to 180 over pi times your radians, or radians is equal to pi over 180 times the degrees. Okay, and so that's our conversion. We're going to go ahead and do a little bit of conversion real quick. So here we go. We want to convert these degrees to radians. So we have 150 degrees. We want to change it to radians. So that means that I am going to be using the one that changes to radians. That would be this one. Right? I want to get rid of the degrees. And the easy way to remember, whatever you want to get rid of, that's the one that goes on the bottom. I want to get rid of degrees, so the 180 degrees is going to go on the bottom. So we have pi over 180 times 150. And you can actually just go straight across like that. And we're just going to simplify this. Easy enough. So let's see, both divisible by 10 would be 15 over 18. Divisible by 3 would be 5 and 6. So we end up with 5 pi over 6. Just like that. All right, easy stuff. Basically, we're just going to write it out, and then we're going to simplify it. It's a little bit easier, actually, if you put the degrees in front of it. So here we have 75 times pi over 180. All right? And we're going to simplify those. Let's see. Both of those are divisible by 15, which would give me 5 pi over 12. All right, all it is. Okay, so let's take a look at the next one. Let's convert it the other way around. So here we go. We are going to convert radians to degrees. So since I'm going to convert radians to degrees, I'm going to use this one. I want to get rid of the radians, so the pi on the bottom. So we have 180 divided by pi times my radians, which is pi over 3. Now, before I multiply this, I'm going to simplify it. Notice I have pi on top and bottom, right? Gone. Cancels out. Now I just have 180 divided by 3, right? Equals 180 divided by 3. And 180 divided by 3 is easy enough. That is 60 degrees. All right, let's do the other one there. Let's see here. So we have 180 divided by pi times 3 pi over 5. Again, we want to simplify this first, so the pi's cancel out. And let's see here. 180 is divisible by 5, so I can cancel that out. That's 180 divided by 5. It becomes 36. So that's 1. So that just leaves me with 36 times 3, and that is 108. And there it is. All right. So that is how to convert radians to degrees, degrees to radians. And the question becomes, what do we do with this? Why do we care about radians? Because when you get up into higher level math, when you get up into college trig or even into physics and things like that, they're going to be looking at angles in terms of radians. All right. So here we go. We want to know how long is the blue arc. And if you'll notice, they gave me the angle in radians, didn't they? How do I know it's radians? 1, because it's got pi, and 2, it doesn't have the little degree symbol there. Okay, so what that means is that this formula here is no good. This formula is in degrees, and I need it to be in radians. Well, that's fine. That's not a big deal. I can fix that pretty easily, actually. All I have to do is come over here and change that 360 because, you know, radians, it's not 360 for a circle. What is it for a circle? Said it a minute ago. For radians, it's 2 pi. And there we go. Now I fixed it. Now it works for radians. Let's change my other formula as well. Okay, so instead of being 360, it's 2 pi. And, oh, would you look at that? We've got 2 pi r theta divided by 2 pi, and that's going to cancel out, isn't it? Which leaves me with just radius times theta. And that's not in degrees anymore. It's in radians. And that comes out pretty nice and easy. That's a whole lot easier than using the degrees, which is why we have radians. All right, let's take a look at this. So we're just going to plug things in. I'm looking for the length. So L there for my length is equal to my radius, 12 centimeters, times my angle in radians, which is 4 pi over 3. Again, I do want to simplify this before I actually do my multiplication. So let's see, I've got 3 and 12. So that's both divisible by 3. That's 4. So now I end up with 4 times 4 pi. And so my length of my circle there is going to be 16 pi. And if I want the exact answer, that's what it is. If I don't want the exact answer, then I want it rounded off into centimeters, then the length of my arc is going to be approximately, stick that in the calculator, 50.27 centimeters. All right. We are going to do one more example. So let's take a look at the last example. All right. So here I want to find x. which is my angle. It's not the length of the arc anymore. Now x is the measure of the angle. I want to find it in radians, and I want to find it in degrees. So I've got the formula up here for radians. Notice I put C, and let's change that. Instead of C, let's put that is 2 pi r, because it's the circumference. So we're just going to fill things in here. So the length is 15 over my circumference, which would be 2 times pi times 9, equals my angle, which I don't know, so x over 2 pi. 2 pi. All right, now I'm going to do cross products. And so that gives me what? So that gives me 2 pi times 15 equals 2 pi times 9x. And you know what? We want to get x by itself, right? So what I'm going to do now is I'm going to divide by 2 pi times 9. 9. That's even worse. Whatever. Divide by 2 pi times 9. And would you look at that? I've got stuff canceling out here again, don't I? This 2 pi and that 2 pi cancels out. And so x is equal to 15/9, which I do want to simplify. That would be what? 5/3. All right, so x is equal to 5/3 in radians. All right. But we also want it in degrees, so let's change it to degrees. We can either do all this work again using 360 instead of 2 pi, or we can just take our 5/3 and convert it to degrees. So I am going to do that. So 5/3 times, is this going to be 180 over pi or pi over 180? Yeah, it's going to be 180 over pi. I want to get rid of the radians, so the pi goes on the bottom. So 180 over pi. And let's see, can we simplify anything there? We can do a little bit. So let's see, what does that do? This is 3 goes away. 180 divided by 3 is 60. 60. And so I have 5 times 60, which is 300 over pi. I am going to stick that into my calculator. 300 divided by pi. And so I end up with x is approximately 95.49 degrees. There we go. We have it in degrees. We have it in radians. Important things to remember. Number one, if you're looking at length, you want the distance around, and this is a proportion based on circumference. All right. So it's going to be the length of the arc over the circumference is equal to the measure of the angle over the measure of the entire circle. If you're looking at degrees, that's 360. If you're looking at radians, wherever they went, whatever. If you're looking at radians, it's 2 pi. All right. So the conversion, again, for degrees to radians, that's 180 over pi. If you want to get rid of radians, you want your answer in degrees, it's 180 over pi. If you want to get rid of the degrees and you want your answer in radians, it's pi over 180. Whatever it is you're getting rid of goes on the bottom. All right. So there's the conversions. And remember, your formula is going to change depending on if you want degrees or radians. Whichever one you want, you're dealing with. If you're dealing with radians, you want 2 pi on the bottom. If you're dealing with degrees, it needs to be 360. All right. Hopefully you found that useful, and I will see you in the next video.